For this week, we will now be talking about tension members. Okay, so we are already done with the first module, which is pretty much the introduction to structural steel design. So we talk about the processes in structural design. We also talk about the loads, the design philosophies, as well as material properties. Okay, so for this week, we will now be starting our lectures on the design itself. Okay, so the first member that we will discuss is the design of tension members. Okay, so our ILOs for this week. So at the end of the module, the students will be able to describe and distinguish tension members in a structure, enumerate and explain the limit states that govern in analysis and design of structural steel tension members, and analyze and design structural steel tension members considering strength and serviceability requirements in accordance to the relevant code provisions. Okay, so our topics here, topics in this module include definition and examples of tension members, gross and effective net area, staggered bolted connections, block shear, and analysis and design of tension members. Okay. So there you go. So let me go with the first part. So first, tension members. So tension members are members that mainly resist axial tension forces. So meaning, tension members are the members that experience pulling force. Okay. So where do we usually encounter tension members in a structure? So first, we have the truss members right here. So if we have, say, a simply supported roof truss here, subjected to loads as shown, some of the members here, especially the members that are marked green, light green here, these are determined to be in tension. So as we know, trusses are structures that are built with axial members. So meaning the members of a truss should only experience either axial tension or axial compression. So in this particular case, the members here, some of the members here experience axial tension. So meaning some truss members are examples of tension members. Same thing with the cables. So for example, we see them in bridges or in towers as well. So these cables support structures in tension only. So in compression, it has no resistance, but in tension, it has strength. Okay. And then we also have the bracings in a building. So for example, if a building is subjected to a lateral force, no? For example, if you have a cross bracing right here, this bracing may undergo axial tension, while this particular bracing here may undergo axial compression. Okay? So bracings may be subjected to either axial tension or actual compression. Okay, axial compression rather. So there you go. These are some of the tension members that we encounter in structures. Okay, so now more especially in structural steel tension members, what are the limit states that we consider? So in our case here in this module, we will only be considering the member limit states. So what do we mean when we say member limit states? We only talk about the strength or the capacity of the tension member itself. So meaning, for now, we assume that the strength of the connections and the strength of the gusset plate. So the gusset plate here is the one that connects the member to another member. Okay, by using connections. So we assume that the gusset plate and the connections are non-critical, meaning they are considered to be adequately designed. Okay. So, so in this module, we will only be considering member limit states. So meaning the limit states that we consider for a member to be considered as in its failure. Okay. So for member limit states, we actually have three: yielding at cross section, rupture at neck section, and block shear. So for yielding at cross section, so for an instance, we have a member here. So these ends are connected, say, by bolts. So the cross sectional area at the part where there's no the connection is not located. So usually the connections are located at the ends of the member, right? So the cross sectional area here is at the part between the two connections. We call it the cross section. So the cross section is the original cross section of the tension member. So now we do not actually want this part right here, the part with no connections, to yield. Why is it that we don't want this to yield? Because if we actually observe, the connected part of the tension member is very short, so therefore it will only experience shorter deformation. However, uh, the no connection part right here, say this part na, so walang connections dito. So meaning buo yung section niya dito. However, this one is very much longer compared to the connection part. So meaning, kapag nag-deform to, it will deform more than the connection part. So meaning, if this yielded, it will actually show more deformation. And we do not want that. Okay. So this limit state is checked considered to prevent excessive deformations on the tension member. So ayaw nating mag-deform ng husto itong part na to, the part with no connection. Okay? Next one, we have the rupture at neck section. So the neck section is the actual cross-section of the member considering the presence of the bolt hole. So for example, we have this one. The cross section is actually located at this part. So since walang butas. And the net area, the net section rather, is located here, na, at a plane intersecting the holes. So this is what we call the net section. In this case, we do not want to develop rupture cracks or failure cracks at these portions. So this particular limit state is considered to prevent rupture or failure of the tension member. So now, if we compare this one at cross section, it is only yielding, but at net section, it is rupture. So maybe you may ask, why is it na hindi na lang natin consider yung yielding at the net section? But hindi na lang natin to hayaang But hindi natin pigilan na mag-yield tong part na to. Hinihintay pa natin yung rupture. Why is it that we do it that way? Precisely because this part is, again, no, like I have said earlier, this one is comparably shorter than the no connection part. Okay? So for example, this particular brace right here, ito yung these are the connected parts. This is the non-connected, not no connection part, right? So itong no connection part na this one is a lot longer than the connected part. Okay? Than the connection part. So what does it mean? Yielding does not mean a thing in that section because you cannot actually observe, no, the deformation here, the yielding here. You do not observe yielding here kasi maikli nga. So meaning kung may deformation man siya due to yielding, you cannot you will not be able to observe it. So you will be able to observe the connection part if there is only rupture, if a failure here is developed. Unlike in the no connection part right here, since this one is longer, there will be more deformation. So therefore, you can actually observe yielding at this portion. That's why we do it this way. Okay. So, and then, so do you have any questions so far? Wala. Okay, so, and then, the last member limit state that we consider is what we call block shear. So, an illustration of block shear goes like this. No? So, for example, we have a tension member. What happens is that it will be broken apart into two or more parts. Okay. So, in this case, there might be a failure pattern such that this one will be left here and this one will be broken off. Okay. So what happens is that there is a tension failure here or tension yielding, no? Tension rupture rather. And then there is shear failure or shear yielding at this point. Okay? So may shear stresses ka dito, may tension stresses ka dito. So it is a combination of tension and shear. So that's what the block shear is. This one dito, it only showed the block shear at the gusset plate. However, we will be assuming that gusset plates here in this case are adequately designed. So meaning we will only be focusing more on the capacity or the adequacy of the member. Okay? But this is how the block shear happens. So this one, hihiwalay siya sa part na to. Okay, so it will separate from this part. Okay? So a more detailed discussion of this one will be in topic 2.4. So I will correct this one. Okay? So it is in topic 2.4. Okay? So again, in actual practice, connection limit states need to be considered. However, for this particular module, it is to be assumed that these limit states are not critical and therefore not needed to check. So for now, we will be focusing more on the member. So we will be talking about this on later modules. Okay. So there you go. So we discussed what are tension members, some examples, where do we see them, and what are the limit states that we consider in analysis and design of tension members. Okay. So let me go to the next page. So the yielding at cross section, madali na siya. So the cross section is just the original cross section itself. So we don't really need to know how to determine. So if you know the shape, you just have to get the area. Kung for example, structural steel shapes, we just refer to the ASEP handbook. Okay?